waiting for you guys. Okay. All right, so I have someone joining in. Please, when you just come in, just drop a message so I know you are in. Like, just comment so that I know you are in. Oh my God. All right, David is saying welcome, Lois. Lois, I don't understand. All right, David is saying welcome, Lois. Lois, I don't understand your emoji, oh, but it's okay. God understands. Then, okay, Precious, welcome. Then, Princess, welcome too. So, all right. So, I think I will go right in to start. How about two people watching? If there's another person you have to call in, please, you can call in. So, I'll start with the question. Today, we are just taking question and answers on endocrinology. This video will be available. So, in case you miss a part of it, I'll try to see if it can be available for watch later. So we just go ahead. Now, endocrinology, like I said it at the start of the video, I'll answer your question, Precious. At the start of the video, I'd mentioned something about the fact that your body is always regulated. That's the way the human body works. Nothing should go out of the normal. So the internal environment is always regulated. And that process is called homeostasis, where I ensure everything stays under a particular level. Now, usually two systems do this thing, endocrine and then nervous system. So today, our focus is really the endocrine system, which is endocrinology. Now, if you have a question, all you need to do is just type it out. So let's just have it. Just type it here, and then, or you can type it on the group chat too. So if there's any question, please feel free to type. I will just be answering the questions as they come in. So I'll start with the basis of what Precious question was. So I'll read out the question and then I'll give the answer. So the basic thing is the hypothalamus is in charge of producing hormones, and the hormones of the hypothalamus are either called releasing or inhibiting hormones. That means on their own they cannot do much. The action is to go and cause another person to release something. Then I also call them inhibiting hormone because some of them, the action is to go and tell someone to stop doing something. So I established that there are 6 hormones released by the hypothalamus. Amongst that, the first and primary one was growth hormone, releasing hormone. So please correct me, please. Releasing hormone. So that means it helps the anterior, and then please, all these hormones act on the anterior pituitary, all hypothalamic hormones. So the hypothalamus is like that CEO or the Oga Pata Pata of the company. So he talks to his manager, which is anterior pituitary, and then that person now talks to every other person. So what happens is that this my hypothalamus is the one in charge of releasing. So once he drops his releasing hormone or inhibiting hormone, I'll mention them: growth hormone, releasing hormone. So that means it's to act on anterior pituitary to cause him to release growth hormone. Number 2 is growth hormone inhibiting hormone. That means what's your action? You go to the same anterior pituitary, but then when you act on it, instead of causing him to release hormones, the growth hormone, you tell him to stop releasing. So that's also called somatostatin. Then one other thing, beyond those two, and I have other people like TRH, which is thyrotropin releasing hormone. That means I cause anterior pituitary to release thyrotropin, also called thyroid stimulating hormone. Then beyond that, I have CRH, which is corticotropin releasing hormone. I cause anterior pituitary to release corticotropin. So who is our corticotropin guy here? Anterior pituitary to release corticotropin. That will be ACTH. So yeah, that is that for that. And Precious, I hope that answers your first question. So please, it is a releasing hormone and inhibiting hormone. Then growth hormone itself, once it is released, we'll just go ahead and do its action. So in this case, the action of growth hormone is to cause growth from the name. And you want details of each of the hormones. But when it gets to, I think it's skeletal muscle, so it will still, in different places, it has its action. But the key thing is that we just know that what's causing regulating its own release. Please listen. What's regulating its own release is that I have a releasing hormone from hypothalamus causing anterior pituitary to release a growth hormone. I also have an inhibiting hormone from hypothalamus causing the anterior pituitary to stop releasing. Another name for that inhibiting hormone is called somatostatin. And there's another inhibiting hormone we have in hypothalamus called dopamine, also called prolactin inhibiting hormone. Yeah, another thing you must take note of still in this connection is TRH stimulates release of both prolactin and TSH. Please take note. Dopamine is inhibiting the release of prolactin. So I think that covers the first question. The second question from Precious. Please, if you have questions, just drop them. I'll see them. Second questions. Miracle More, thank you so much. Thank you so much for the comment. Now, okay, Precious, I'm glad to hear you understand what I'm doing. So the second question says, please, can you throw more light on how protein and peptide hormones enter the lipid membrane? All right. So I'll start by debunking that they don't enter the membrane. So this is the idea. We must know what are the characteristics of a cell membrane, what are the characteristics of proteins, what are the characteristics of lipids. So that is where we have to start from. The cell membrane is made up of is a bilipid layer. That means it is made up of principally bilipids. That is lipids. And then one key thing we have that we know about lipids is that lipids allow, thank you very much, Angelica. What we know about lipids is that lipids allow free passage of their fellow lipids. So I don't know if you've tried using oil before. If you should put oil, maybe granule oil, any kind of oil, and you mix them, they will mix so well because they are both lipid soluble. But funny thing is, if you try to mix granite oil or coconut oil or any form of oil inside water, because they are insoluble, you observe there will be a discrepancy. So that's what happens here. Listen very carefully. The things that can cross the lipid membrane must be lipid soluble. So ideally, proteins are water soluble. So please, I've started with the first thing. What is the characteristic of a cell membrane? It is lipid soluble, allowing only lipid things to pass. When it has to allow other things to pass, that's where we have intrinsic proteins and extrinsic proteins, which were meant to help pass necessary things like glucose, amino acids. Beyond that, what will they help? Meaning to help us to pass water. Water is quite important, and some electrolytes. But in this case, when I have an hormone coming in, we need to know which kind of hormone are you. Number one, we have three classes of hormones. Number one was protein and peptides, and those guys are so wonderful. They are soluble in water, so that means they can never cross the membrane. So every single time a protein and peptide hormone gets to the target tissue, he binds to its receptor on the cell membrane. So please take note, it can never cross the membrane. So when it binds on the cell membrane, that will not be enough to do an action. So it will bind to the receptor, but that receptor is usually coupled to an enzyme within the cell. So that means I want to do something inside, but I cannot go inside. So I just bind on the outside, tip someone off that will help me talk to the person inside. So that's called second messenger mechanism. And that what proteins and peptide hormones do. That's number one class. Number two class is amines. Amines, there are a number of them. Dopamine, I think there are five in number. Dopamine, noradrenaline, and adrenaline. They will have the thyroid hormones. So these people here call amines. Funny enough, these amines have the same characteristics. They should have the same characteristics as my protein and peptides, which is being soluble in water and binding on the outside, but except thyroid hormone. So when I come to the class of amines, please take note. All amines except thyroid hormone. Yeah, welcome Nelly Bassi. All amines except thyroid hormones. All amines except thyroid hormone are soluble in water. And because they are soluble in water, they have the similar characteristic as protein and peptides. They will just go and bind and cause second messenger mechanism. But whenever I deal with thyroid hormones are not soluble in water. They are carried by transporters or carrier proteins. There are different names. Please, if you have missed any part of this, you can ask questions. There's some questions I'm answering. Please, and as you are coming in, if you have a question, just drop it here or you can drop it on the group. Come about Siema. If you have a question, just type it. I'll give an answer to it. Thank you very much. So I go on now. So thyroid hormones are now carried by things, carrier proteins. So once they are carried, what is the target? I carry them to the cells. Because they are lipid soluble or they were not soluble in water, they can pass freely inside. So that's the thing. Then when I go to steroids are cholesterol based. Welcome, Mary Bat. Steroids are cholesterol based. So they have no option. They have to cross the membrane. So they are lipid soluble, they cross the membrane freely. Where is their target receptor? Their receptor is within the cytoplasm. And please, what was the receptor of thyroid hormones? Within the nucleus. So that means they will cross the cell membrane, cross the cytoplasm, and get to the nucleus to relay. So very quickly, I'll recap, and I hope you get full clarification. So when I want to understand action of hormones or mechanism of action of hormones, I must know three things to consider. Number one is, which is, what do I know about cell membrane? Number two is the hormone itself. So what is the hormone? Is it lipid soluble or water soluble? And then where is the site of receptor of that hormone? So let me pick the first person. So the cell membrane pattern, it is lipid soluble. So it only allows things that are lipid soluble. So if you are water soluble, you either have to be able to be passing water. If you are a hormone and you're water soluble, you cannot cross. You can never cross. Now let's come back to the hormones. We have three classes of hormones: protein and peptides, which are water soluble. So that means they cannot cross. And then because they are water soluble, they will just be moving freely in blood, no issues. But when you get to the target cells, you cannot cross. So where will your receptors be? On the cell membrane. So we call them membrane receptors. Now I go to the second one, amines. All amines except thyroid hormones are similar to protein and peptides. So that means that soluble in water, do not require a carrier protein, have their membrane, their receptors on the membrane because they can membrane. They're not even in the cytoplasm. They'll go in as far as going into the nucleus. So their receptor is actually on the nucleus. On the nucleus. So we call them nuclear receptor. Then the third person has steroid hormones. Steroid hormones are quite wonderful. They're insoluble, they're lipid soluble, so they're insoluble in water. So I cannot have them flow in water freely. They need a protein. Usually, albumin is that guy. Albumin is the transporter for them. So I'll pick the albumin and then it will just flow. Then where is the end target for my people? When you flow to your target tissue, you cross so freely. And where is their receptors? The receptor is within the cytoplasm. All right, so that is that for that. Precious. Thank you very much. I believe we understand the second question. Please, I'm waiting for other questions. Please don't consider any question stupid, no matter how funny you might think. No matter, as far as there's something that is contradictory in your mind, please ask. I will give you clarifications very quickly. So I've answered two questions so far. One having to do with growth hormones, so the hormones released by the hypothalamus and what they do to the anterior pituitary. Then the second question had to do from still precious. Thank you so much for asking your questions. Having to do with hormone receptors, their site, and how they are able to cross the membrane or not. So please, I'm waiting for more questions. I wait question. Please type your question. I really hope you have questions because that's what will help you learn more from the class. All right. So while we await the question, there's something called, I don't think I outrightly spoke about it in the video, hypothalamo-hypophyseal axis. Hypothalamo-hypophyseal axis. So I would like you to listen. Now, there's a connection between the hypothalamus and the pituitary gland. There's a clear connection between the hypothalamus and the pituitary gland. And this connection, please listen very carefully. You have a question you ask very freely. It's called hypothalamus, hypophyseal axis. Now you could ask me, why are we bringing hypophyseal? The pituitary gland is also called the hypophysis. The one in front is called adenohypophysis, and due to their origin, the one behind is called neurohypophysis. The one behind is gotten from the neural tissue. It's actually a nervous tissue. So you just have neuronal fibers. So that's why we call it neurohypophysis. The one in front, called adeno, is in charge of producing hormones. He's the one that's really the key guy, the anterior pituitary guy. So yeah, that is that. So when I say hypothalamo-hypophyseal axis, it is what will connect the hypothalamus on top with the pituitary gland. Now the connection is two ways. The first one is in front between hypothalamus, listen very carefully, and anterior pituitary. We call it hypothalamo hypophyseal portal system. You remember what a portal system is? Yeah, a portal system is a part where the normal way we have arterial supply or blood supply in the body is that arteries carry blood to a particular place. As they move blood away from the heart to a tissue. At the tissue, you have a capillary bed. From that tissue, what picks it up is should be a vein that returns it back to the heart. So it is a cycle. Artery from heart down to the tissue. So here I have capillaries. Then from capillaries, you join up again to form what? A vein, returning it back to the heart. So now the big question for me and you, of course, would now be what is so special about my artery here? That's a big question. What's so special about the portal system? A portal system is when I have an artery coming, I supply a capillary bed. Ideally, it should be a vein, right? So the vein moves out. But instead of going back to the heart, the vein now stops somewhere else to supply another person. Please listen very carefully. Yeah, welcome, Kuyik Owobia. Welcome, Nadeshda. Oh, God, you have to forgive me with your name. You have to forgive me with your name, but welcome. So now the king now is, please listen very carefully. What is worthy of note in what I just said? In a portal system, a normal system, so let's go back. Blood supply from artery, blood leaves the heart, comes way to the target tissue. I use my capillaries. From capillaries, you pick up from your target tissue, you go back to the heart, and that should be what? Veins. Precious to send there, welcome. Merry Christmas to you too. Now, you go back. Now, that is a normal way. But what if blood should leave the heart, come down, goes to the target tissue, supplies capillaries? That should be artery to capillaries. From capillaries, it turns to vein. But this vein does not go back to the heart directly. It now goes to somewhere else, where to now supply other capillaries. That is called a portal system. So a portal system is when I have something out of the normal, a particular vein. Of course, we have venous portal and then arterial portal, but I'll be using venous here. The venous portal system here will be that I'll pick it from my capillary bed, but instead of going back to the heart, I supply someone else. So that's what happens in between the hypothalamus and the anterior pituitary. Usually, the hypothalamus is supplied by an artery. That's called superior hypophyseal artery. Superior hypophyseal artery. So once the artery supplies the hypothalamus, of course, it will have the capillary bed. Of course, that capillary bed is called primary capillary plexus. So I just supply the anterior pituitary. So when I supply it, sorry, I'm saying anterior pituitary, that will be hypothalamus. So these guys will just release hormones that will enter this pituitary. Once these hormones are picked up by the vein, instead of the vein picking the hormones from hypothalamus and returning it back to the heart, the veins carry these hormones down to anterior pituitary. And when it goes to anterior pituitary, to now do another capillary network, and that is called secondary capillary network. Secondary capillary network. And so I have a primary, listen very carefully. Anterior, what supplies the hypothalamus is superior hypophyseal artery, who breaks down into capillaries called primary capillary plexus. Okay, so now when the hypothalamus releases those releasing and inhibiting hormones, they are carried by this from a plexus, from capillary, who should I be having a vein, but the vein should be going to where? The heart. So instead of this vein going back to the heart, the vein chooses to go down the anterior pituitary. So that vein is called a portal vein. And when it goes to the anterior pituitary to now give capillaries, these capillaries are called secondary capillary plexus. So the direct connection is that stuff. But beyond that, of course, this is the infundibulum that will attach hypothalamus to anterior pituitary. And then you should know in histology that anterior pituitary is made up of three parts. Pars tuberalis, pars media, and then which other one? Okay, I think that's the pituitary gland as a whole. But you should have a tuber part, tuberalis, yes. And then you should have an intermediate part too. And then I think we have nervosa for the past and the back side. So, but yeah, that's just that for that. All right, so please, I'm open for questions. So that's anterior. So we call the hypothalamo hypophyseal portal system. So that is between anterior pituitary in front and then hypothalamus. But between hypothalamus and posterior pituitary, there's no blood supply connection. The truth is that the neurons in the hypothalamus have the axons descending down. So it is those the axons that actually make up the posterior pituitary. So the posterior pituitary does not even have its own cells. Maybe apart from this thing we mentioned, tracts. And I know you know why I'm using the word tracts. As we've learned, tracts are just axons. So that's why I say the connection is hypothalamo hypophyseal tract. So I think I'll be calling you by name and asking you for your questions. David is saying, I'm waiting for your question. Lois, I'm waiting for your question. Lois, I don't know you had someone in your name. Who again do I have here? Precious. Thank you so much for your questions. Princess, I'm waiting for your question. Ukomonde, Wisdom, Nsika, welcome everyone. Miracle, Angelica, Nelly Bassi, I'm awaiting questions. Penia Udo, Basema, Mary, and I have Owobia here with me. Nadishda. Nadishda. Yeah, I think that should be it. I'm Precious. So yeah, please, if you have questions, let of course posterior pituitary will just release oxytocin and then who again? ADH. It's actually from my hypothalamus. All of these things is coming, and we are told they're released by neurons in the hypothalamus. Those neurons are called. So there are two of them actually. Supra optic nucleus. So there are two of them, and then what is the other guy called? Paraventricular nucleus. So the two of them produce these two people, oxytocin and ADH. But we are told that there are some predominance. So I use the acronym saponification, SAPO, maybe SAPA, but SAPO. So a supra optic tends to produce more of ADH, whereas paraventricular tends to produce more of oxytocin. Though they can both produce the two of them, but at least who do they produce the most, please? Supra optic produces more of ADH and then paraventricular produces more of oxytocin. Please, is there any question? I'm still listening for your question. Please tell me there's a question now. There's a question. Can't just come to be looking at my face, please. All right, at least someone should answer me so that I know I'm being heard. Someone should just type so I know I'm being heard. Please, am I being heard? Oh, okay, okay. Thank God for precious. Oh, the two preciouses. All right, so with the same spirit you used to type, please give me questions. I'm waiting for you. All right, so I think beyond that, while I'm awaiting your question, let me see if there's another thing I could mention too. So still in my tract, so the things anterior pituitary releases go on to affect other people. So, but the quick question is, who does anterior pituitary release? Number one, follicle stimulating hormone. Of course, you know from reproductive physiology that will go to the target of follicle stimulating hormone will be the gonads. So both in males and females to do their function. Then beyond that, I also have my luteinizing hormone, something similar, which are the gonadotropins. So from the name gonadotropins, they help the gonads to grow and then to release their hormones. All right. So beyond that, any other thing we should know? The other hormones we produce, we have growth hormone. Growth hormone does not act on any other person to cause the person to release. His own action is straightforward. He goes to do its action, so it affects its action. Then beyond growth hormone, other people we can have. mm, Other people can have release days. Thyroid stimulating hormone will stimulate thyroid gland to produce thyroid hormone. And we have, which other hormone do we have here? We also have adrenocorticotropic hormone, which will help the adrenal cortex to produce its own hormones. And yes, please, in my video, I forgot to add that someone pointed that out to me. Good out shout to Goodman. I did not remember to add that while I was talking, but I hope you are here. Now, I mentioned steroid hormones. Please take note. All adrenocortical hormones are steroid hormones. All, all. They are produced from cholesterol. That's steroid hormones. So I think that is just that for that. Any other question? All right, please. I just need to know, is there any other question before I could? Okay, thank you very much, Angelica. I see your message that you can hear me. Thank you so much. All right, Precious says, Chief, I saw somewhere that prolactin does not exactly have a stimulatory hormone, that it's constantly being released. Then PIH only functions to stop prolactin release when in excess. I don't know if it's true. It's all right. Thank you very much for the question. Yeah, see, the truth is, according to the books, of course, my reference here is Constanzo. Constanzo clearly outlines that prolactin release, there's nobody that will really say this is the prolactin stimulating hormone, but prolactin release is also due to thyroid stimulating, sorry, thyroid. All right, so I think you hear me better. Are you hearing me now? All right, all right, all right, all right, all right. Sorry, sorry. I'm having a lot of rope. Can I be heard right now? Let me know right now. Can you hear me right now? Okay, Basima says she can hear me. So please, I'll repeat myself. So I'll be answering Precious' question again. All right. So let me try answering Precious' question again. So I was saying his question was quite direct. Prolactin. You found somewhere that prolactin doesn't have a stimulatory hormone. Rather, it has an inhibiting hormone. So I want to correct that notion. My source is Guyton. I want to correct the notion. Prolactin, the release of prolactin, there's nobody who outrightly call prolactin stimulating hormone. That's all right. But the person that causes the release of prolactin, the person that causes the release of prolactin is TRH. Please, who is TRH again? Don't know if it's low. All right, so let me try out something. Am I being heard right now? Let me try this out. Let's see. Am I being heard? Yeah, welcome, Elud Bokeh. I can't tell who it is. Please, are you hearing me right now? Sorry, Precious. Are you hearing me right now? I've like taken out. I'm not using this again. Can you hear me now? Please, I need to know if you are hearing me. All right. Please, sorry, 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 sorry. Yeah, I think it's the mic I'm using it's low, so I have to fix that. But at least for now, let's focus on what I said before. So I mentioned prolactin. So let me hit back on that. So the question was simple: prolactin. Is there any prolactin stimulating hormone in a named prolactin stimulating hormone? No. But is there anybody that can stimulate the release of prolactin? Yes. Who is that? Thyrotropin releasing hormone. So TRH has two roles. It is able to stimulate the release of thyrotropin stimulating hormone. There is thyroid stimulating hormone, which is thyrotropin. Please forgive me for this mixing up of the words. Let me go over the word. It is called thyroid stimulating hormone or thyrotropin. Thyrotropin or thyroid stimulating hormone. So I repeat myself, thyroid stimulating hormone or thyrotropin. No, I'm not Mexican, I'm a Nigerian. So now, beyond that, please, I'm just answering a question from Robert. Robert, I'm not Mexican, I'm a Nigerian. All right, so that is just that. So please, prolactin is the release of prolactin is stimulated by thyrotropin releasing hormone. Thyrotropin releasing hormone. Thyrotropin releasing hormone. So please, and then it is inhibited by who? Prolactin inhibiting hormone called dopamine. So let's get this very clear. It is quite simple that whenever I mention the word prolactin, who causes its release? TRH. From where? Hypothalamus. Who inhibits its release? Dopamine. From where? Hypothalamus. So yeah, that is that for that. Any other question in this wise? All right, so this was a question from Precious. Precious is saying there, do you now understand? Are we good? Can I go to something else? And please, if you have any other question, feel free to mention that. All right, so Precious says he's good. So I think me, I'm good too. All right, so beyond that, I think that's just the basic thing. Okay, yes, please. Robert, you can go ahead. All right, so that's just that. So I think another thing I might have not mentioned in the video, another thing I might have not mentioned in the video was the case of the mechanism of regulation. Please let's listen. How is hormonal secretion regulated? How is hormonal secretion regulated? Please. The release of hormones is regulated majorly by two things. Listen very carefully. It is either a nervous mechanism or an hormonal mechanism. Nervous or hormonal. Nervous or hormonal. So whenever I say an hormone is released, its release is either due to stimulation by the nervous system or it is released by due to stimulation by the hormonal system. So please let me see this question from Robert. In some African American people say that people that are born in Africa don't like black people that are born in America. All right, I think it's contextual. I can't really tell for sure. So the question is, some African American people say that people that are born in Africa don't like black people that are born in America. Okay, of course, I don't share that as an opinion myself. I'm good with. I don't think of the rest. I'm good with it, and any way someone is born is it's quite fair for me too. So that's not a problem for me. I don't think most of the people share it. Maybe just a notion that might not be true. It's just a notion that might not be true. All right, thank you very much, Robert. I hope that clarifies what you asked. So let me go back to the regulation of hormonal secretion. Now, for hormonal secretion, let me be quite clear. Nervous mechanism, it is quite rare. It is quite rare. It is quite rare. The only time I have to mention nervous mechanism is in alarm stress response. Now, in introductory physiology, when you were taught, or at least based on whatever level is taught, ANS, autonomic nervous system, we are told of the fact that the sympathetic nervous system usually showcases a particular type of response when it is in a stressful condition or in a condition where he wants to run. You are frightened. So when you are in a condition that should bring in fear, so you are frightened, and what do you choose to do? You choose to either fight or run. So it is called FFF, which is that is fear, flight, or flight response. So you choose to now run out or stay. And so that is just that for that. All right, so what happens here is that usually whenever that response is kicked in, the sympathetic nervous system acts on the adrenal medulla and causes him to release adrenaline and noradrenaline. The person we release more is adrenaline. About 80% is adrenaline. The person that will release in less is now noradrenaline, 20%. But the key thing is that they are carried in blood as hormones and they do the action everywhere.
So that's nervous regulation. But I have hormonal regulation where an hormone is regulating another hormone. And like we've seen, an example is that hypothalamus hypophyseal axis, where the hormones of the hypothalamus are regulating the hormones of the anterior pituitary. So that is just that for that. And beyond that, I can also have other examples where a hormone is regulating another hormone. Think of anything. So beyond that, yeah, another thing is feedback. I don't know if you've heard of feedback mechanism, but feedback is a case whereby the hormone that is released as part of its action. So I could do a particular action, but a part of my action is to go back and regulate who released me. So let me use an example of a tract. Let me use a tract that is quite conversant with us, and I'll use from hypothalamus. I release gonadotropin releasing hormone every single day of a woman's cycle, every single month. At the start of our menstrual cycle, gonadotropin releasing hormone is released, and that hormone will act on anterior pituitary to release follicle stimulating hormone and luteinizing hormone. What's the action? They go down to the gonads. So if I'm dealing with a woman here and cause the follicles to grow, and over as they grow and they develop, ultimately they do ovulation. But just before ovulation, we are told that at every level, as follicle stimulating hormone is as the follicles are growing, those people release estrogen and progesterone. Funny thing is that estrogen that is released, listen very carefully, estrogen release feedback. So the feedback could be negative. When I go back and tell you stop, don't release again now. Feedback could now be positive, like the case in women's cycle where we see around the day 13 before ovulation. It will go back and tell the guy, alpha, spike up, spike up, spike up, produce more luteinizing hormone. So that's called positive feedback. So please, positive feedback, or would I say feedback mechanisms, are just the fact that a mechanism whereby a part of the action of the hormone goes back or fits back to someone that can regulate him. So I go back to regulate the person that caused my secretion. It can be positive if what I'm going back to do is to tell him to release more of me. But it will be negative if what I'm going back to do is to tell him to stop reducing me. And the only examples of positive feedback we have is really oxytocin, and then that's one I mentioned, the estrogen action on luteinizing hormone surge mid-cycle for females. Then beyond that, the other one is that I could also have oxytocin during parturition, that's during labor, when women want to put to bed. The woman, once contraction starts, we are taught that the contraction is due to the action of oxytocin on the smooth muscle of the uterus. So once the smooth muscle of the wall of uterus start contracting, oxytocin binds, they contract. As they contract, they feed back to cause posterior pituitary to release more oxytocin. More oxytocin release will now bind, cause them to contract more. As they contract more, they go back. So it is that the hormone, the action of the hormone is to ultimately make you keep releasing more of him, releasing more of him. That's called positive feedback. But aside from that, the most things we see is negative feedback. Conditions whereby, for example, if thyroid hormone is high, I'll go back and tell you to stop producing it. Thyroid hormone is low, I'll go back and tell you to start producing. So that is the idea. And please, in feedback mechanisms, we have three types of feedback. Negative feedback loops, a feedback mechanism generally, three types of loops. We can have long loop, which is from the end target. So what the end target tissue produce can go back to either anterior pituitary or hypothalamus. We have short loops, where from anterior pituitary I go back and regulate hypothalamus hormones. Then the third one is I can also have ultra short. So ultra short loop is that I release something within me and you also release something that can inhibit me. Funny enough, we are told an example of that is that growth hormone in releasing hormone, its action is to cause release of growth hormone. But also here we have another person called growth hormone inhibiting hormone who can inhibit the release of the hormone releasing hormone. So yeah, that is just that concept of hormonal regulation. Is there any question in that wise? David is saying, are you still here? Do you understand what I'm doing? Should I repeat myself? Lois, I've not heard you say anything from the start except for when you dropped. And emoji I don't understand. Is there any question? Welcome. I'm seeing a Carl Yuch. I don't know. I hope I'm pronouncing your name right. Welcome. Hey, hey too. Carl, I think Carl is yeah. So please, Angelica, are you following me? Is there anything I need to clarify? In Sika, Ndon, anything I need to clarify so that we can call it a day? Any question I need to clarify? Please, I'm awaiting any comments from you guys. Alright, I hope I'm being heard. I need to know. I want us to like. I want to know if there's any other question, or we can call it a day. Precious, are you still here? Yeah, welcome gospel. Welcome gospel. Oh, Mama, welcome. Ma. There's any other thing we need to clarify before we call it a day? All right, all right, all right. Okay, yeah, wisdom. What was the full class you knew? Because there are even five. It's based on who is teaching you. Wisdom, I've seen your question. Yeah, what's the full class you know about? Please, you can just type it out. What's the full class you know about? I mentioned the three major classes you see in almost every book you pick up to read, but there's even two other classes too. But let me know which one do you know too. Because we put nitric oxide. Please, can you repeat what you said about long group, short? Okay, okay, I'll repeat that. Oh, no, 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 please. Protein and peptide is not separate, please. Wisdom Okon, thank you very much for mentioning. They are not separate. So if you are giving this, no, please, it should be three classes, which will be protein and peptide as one class, steroids as another class, and then amides, yeah, that's amines as a third class. So those should be the three classes. Universally known. We have some other classes, like we have some that we call local, which are nitric oxide, and then that goes through. So please, that covers that. Then I'm seeing a question from Angelica to repeat. No, not short group, long group. It's short loop, loop. L-O-O-P, short loop, long loop. Let me mention it. If let me use an example. If estrogen and progesterone, which are released by the gonads of females, should go back to feedback on anterior pituitary or hypothalamus. So from an end target tissue, you go back to the oga pata patas. It's called long loop. If anterior pituitary should feedback on hypothalamus, it is called short loop. But if hypothalamus should feedback on itself, or anterior pituitary should feedback on itself, that is called ultra short loop. Angelica, please, does that answer your question? I repeat myself. There are three loops in feedback. If I have a feedback from end target back to the primary organs like anterior pituitary or my hypothalamus, which is in the brain, I'll run with long loop. If I move from my anterior pituitary to hypothalamus, that's short loop. Then if I now move from, yes, Precious, I'm repeating that. Precious, I'm repeating what Angelica is asking about. If I move from end target back to the anterior pituitary or hypothalamus, that is called what? Long loop. If I move from my anterior pituitary to hypothalamus, something will still. So for example, let's say I release something from anterior pituitary and that stuff comes back to inhibit someone else in anterior pituitary. Or I release something from hypothalamus, that stuff comes back to inhibit someone in hypothalamus. That is called ultra short loop. So those are the three loops of concern. So I hope that's what Angelica wanted. And that should mean we are good. So if there is any other question, okay, Angelica says yes, Chief, thanks. So I think we are good. Thank you very much for joining in. I really appreciate you posting of this class. I wanted this to be as short as possible. If there's any other question, I would entertain that. But at least let me just go through calling each name to congratulate you for coming in. David Essien, thank you for joining. Lois, thank you for joining. Precious Night, thank you. Princess Ada, I hope you're still around. I did not see you talk again. Lois too. Kumonde, I'm not sure I still saw you again. Wisdom, thank you for being around and being active. Precious Night, I think you have to win the award. You've been active today. Isikak, Miracle Mo just dropped thank you and he did not come again. Angelica, yeah, good. Nelly Basi, Penio, Basiama, Mary, Nadieshda. I've not heard her say anything other than greeting me. Quick, same thing. And then I think those are the names people have had reflect a lot here. Okay, I saw Elliot Bouquet, welcome, saying hi. And then also Robert, thank you for joining. And then Carl, you, thank you for joining. My own mama, Gospel Rails, thank you so much for joining, ma. All right, thank you very much, everyone. So We are good. Thank you very much. We'll continue from there next time. And any other thing, I'll try to make this video available so that people that could have to join in some other time, like probably watch it after. And if you have to go back through it, you can go back through it. And then you can watch the real video. To in case there's anything you need to clarify, go back to the real video. I'll make other videos available on endocrinology, and let's see how we could tackle it out during this festive period. Thank you so much, and God bless you. Have a wonderful day.